Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code DTC P0193 indicates a high-voltage condition in the fuel rail pressure sensor circuit of the Honda Civic models from 2011 to 2015. This can occur due to a variety of issues within the fuel delivery system specifically related to the fuel rail pressure sensor's functionality. The fuel rail pressure sensor monitors the pressure of the fuel inside the fuel rail and provides this information to the powertrain control module, PCM. The PCM uses this data to adjust the fuel injection system for optimal engine performance. A fault in this circuit could lead to engine performance issues and affect the overall drivability of the vehicle. Recognizing this code requires the use of diagnostic tools, including the Honda Diagnostic System, HDS, to effectively troubleshoot the issue. The fuel rail pressure sensor is a pivotal component in the fuel delivery system of the Honda Civic. Located on or near the fuel rail, this sensor measures the pressure of the fuel going to the injectors and relays this data to the powertrain control module, PCM. The PCM interprets this data to precisely manage fuel injection, ensuring the engine operates efficiently. The high voltage condition indicated by DTC P0193 suggests a potential malfunction within this sensor or its circuit connections. Additionally, the fuel pressure control circuit, which includes the PCM's control over the fuel pressure regulator, can also be implicated in this fault. A thorough examination of the sensor and the integrity of the connections to the PCM is critical to resolving this issue. Several potential causes contribute to the activation of DTC P0193. One common issue is a short circuit in the wiring of the fuel rail pressure sensor, which can cause erratic sensor readings. Another possibility is a malfunction of the fuel rail pressure sensor itself, which may need replacement if found defective. Poor connections, either at the fuel rail pressure sensor or at the powertrain control module, can lead to faulty communication and erroneous voltage readings. These causes can often lead to intermittent failures, making thorough inspection a necessity to pinpoint the underlying problem. The symptoms associated with DTC P0193 are noticeable and can significantly affect the vehicle's drivability. Drivers may experience engine performance issues, including stalling, rough idling, or poor acceleration. There may also be difficulties in starting the vehicle, particularly in cold weather, as indicated by the testing conditions requiring ambient temperatures above 32 degrees Fahrenheit or 0 degrees Celsius. Additionally, a faulty sensor may lead to an improper fuel mixture, potentially causing a fuel odor in the exhaust. Drivers may also witness warning lights on the dashboard, indicating engine management problems. Recognizing these symptoms early can prompt timely diagnostics and repair, preventing further complications. The first step in troubleshooting DTC P0193 involves basic problem verification. Start by turning the ignition switch to the on position, also known as I. Using the Honda Diagnostic System, HDS, check the fuel pressure sensor reading in the data list. The ideal voltage reading should be approximately 4.5 volts or higher. If this condition is met, it indicates that the issue may be replicable. However, if the reading is lower, it suggests an intermittent failure, and further investigation into potential poor connections or loose terminals that both the fuel rail pressure sensor and the PCM is needed. Additionally, collecting freeze data and onboard snapshots can provide valuable insights during troubleshooting. In the second step of troubleshooting, attempt to start the engine, ensuring that the ambient temperature is above 32 Fahrenheit, 0 degrees Celsius. This is crucial because a cold start condition can affect system performance and sensor readings. If the engine starts successfully, This points towards a possible issue in the fuel pressure control circuit or related components. If the engine does not start, further diagnostics will be necessary to explore other potential failure areas. This step effectively filters the possibilities, focusing the attention on the critical components that could be contributing to the DTC P0193. For troubleshooting step 3, begin by turning the ignition switch to the lock position, denoted as 0. Next, disconnect the fuel rail pressure sensor by removing its 3P connector. With the sensor disconnected, turn the ignition back to the on position. Observe the low fuel indicator in the HDS data list. If the indicator shows off, it confirms that the CNG FSRYCL wire is functioning properly, suggesting that the issue lies elsewhere, potentially with the fuel pressure regulator. In such cases, replacing the fuel pressure regulator P1 would be the next logical step. If the indicator is on, it shows a short circuit condition needing attention. Proceeding to step 4, start by checking the fuel pressure sensor again with the HDS after recording the initial value. This step involves several actions. First, turn the ignition switch to lock 0 to ensure all systems are reset. Following this, close the manual shutoff valve and then start the engine. Allow it to idle until it stops and subsequently check the FP sensor reading once more. Comparing the current value with the prior reading determines whether there has been a drop in the sensor's output, which would signify a fault in the fuel rail pressure sensor, circuit, or associated wiring. If there is a decrease in voltage reading, this leads to further investigation as per step 5. In this step, the procedures align closely with step 3. Begin by turning the ignition to the lock position before disconnecting the fuel rail pressure sensor 3P connector. With this disconnection, switch the ignition back to on 2 and assess the low fuel indicator within the HDS data list. Should the indicator display off, it indicates that the CNG FSRLY-CL wire is in good condition, leading to the recommendation to replace the fuel pressure regulator P1. However, if the low fuel indicator is on, it indicates a short circuit exists in the line, requiring repairs along the circuit, leading to the PCM and fuel pressure regulator switch, alongside the replacement of the fuel pressure regulator P1. Moving on to step 6, the procedure includes turning the ignition switch to the lock 0 position and subsequently disconnecting the fuel rail pressure sensor. After disconnecting, the next action is to connect terminals A and B using a jumper wire. Terminal A connects to the fuel rail pressure sensor number 1, black, and terminal B connects to the fuel rail pressure sensor 3P connector number 2, purple. Turn the ignition switch to on, I, and monitor the FP sensor reading in the HDS. A reading of approximately 4.6 volts or greater is necessary. If the reading is satisfactory, proceed to step 7. Otherwise, if the voltage is inadequate, replacing the fuel rail pressure sensor becomes essential to resolving the high voltage error. The 7th troubleshooting step involves removing the jumper wire that was previously connected in the prior step. After this, turn the ignition switch back to the on I position for testing. Measure the voltage between 2 crucial test points. Test point 1 is the fuel rail pressure sensor connector number 1, black, and test point 2 is the fuel rail pressure sensor connector number 3, red. Performing this voltage test while ensuring that the fuel rail pressure sensor remains disconnected allows for proper diagnostic data collection. A voltage measurement of around 5.0 volts is expected. If this voltage is confirmed, it suggests that the electrical supply to the sensor circuit is intact, prompting progression to step 9 for further verification. In the 8th step of troubleshooting, You start by turning the ignition switch to lock 0 once again. Use the Honda Diagnostic system to jump the SCS line. Following this preparation, disconnect the PCM connector A, which is a 49P connector. The next action is to check for continuity on the SG6 line between test points defined within the procedure. Continuity ensures that the wiring between the PCM and the fuel rail pressure sensor is sound, eliminating any open circuit issues. If continuity is present, the SG6 wire is validated, necessitating either a PCM software update if outdated, or substituting with a known good PCM to eliminate software-related failure causes. The final troubleshooting step focuses on validating the PF2 line comprehensively. Begin by returning the ignition switch to the lock 0 position before following the routine of jumping the SCS line with the HDS. Disconnect the PCM connector A, 49P, solely for this check. You will then check for continuity between the two defined test points on the PF2 line. Successful continuity indicates that the wiring is intact and functional. If there is continuity, this shows the wire is not the root cause, leading to potential PCM software updates or substitution with a known good PCM. Failing to find continuity necessitates repairs on the PF2 wiring, leading to the fuel rail pressure sensor to rectify the high voltage issue identified by DTC P0193. Upon completing repairs, the final verification process is critical to ensure that DTC P0193 has been resolved effectively. Start by reconnecting all previously disconnected connectors, ensuring that no loose terminals or poor connections remain. Next, turn the ignition switch to the on position, II, to reinitialize the system. The Honda Diagnostic System, HDS, should then be utilized to check for any pending or confirmed diagnostic trouble codes. If DTC P0193 reappears, this indicates that further inspection is needed, specifically looking for issues related to connections or the PCM updates. A determination that no DTCs exist confirms successful repairs, allowing for the conclusion of the troubleshooting process. Preventive maintenance is essential to ensure long-term reliability and avoid recurrence of DTC P0193 in the future. Regularly inspecting wiring for signs of wear or damage helps to identify potential issues before they develop into failures. Furthermore, keeping the powertrain control module, PCM, software updated ensures that the latest performance and reliability enhancements are in place, minimizing the likelihood of erroneous sensor readings. Cleaning and securing all electrical connections, especially at critical components like the fuel rail pressure sensor and PCM, will prevent intermittent connectivity issues that could lead to erroneous DTCs. Emphasizing these proactive measures will extend the operational longevity of your Honda Civics fuel system. In summary, DTC P0193 provides crucial information about a high voltage condition in the fuel rail pressure sensor circuit, which can lead to significant engine performance problems if not addressed. Understanding the associated components, such as the fuel rail pressure sensor and the PCM, is essential for effective troubleshooting. Common issues often stem from wiring shorts or connection problems, highlighting the importance of diligent inspection during the troubleshooting process. Implementing regular preventive maintenance practices will be vital in extending the reliability of the fuel system and minimizing the risk of future DTC occurrences. For Honda Civic owners, being proactive ensures that their vehicle remains in peak operating condition. Please like and subscribe to the channel. See you next time.